ऑर्डर किया मैंने, मुझे था ऑफर था 150 से।
आप कर दो, आप कर दो, आप ऑर्डर कर दो।
तो तूने ऑर्डर कर दिया क्या? हाँ, कर दे। क्या करूँगा, क्या खाएगा? मैं तो कुछ नहीं खाऊंगा। तो थैंक्स थैंक्स। उस दिन वाली बिरयानी मंगा रहे हैं?
Hello guys,
थैंक्स
guys we're
थैंक्स।
live now. Hello,
हेलो हेलो।
Anustup and Anustup, we're live now. You guys can carry on. Or we can wait for the audience now. Just hold on. Okay.
सौ के बनता
Over
है।
to you,
वेट फॉर द
just
ऑडियंस।
hold on for the audience and do as per your needs.
ओए ओए अभी 100
बॉस।
का फ्रेंच फ्राइज 100 रुपीज का। वो स्पाइसी नहीं होना चाहिए, सिंपल।
हेलो एवरीवन, हेलो 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 हेलो। 5 watching now. हेलो। Hello everybody. A very warm good afternoon to one and all. Let's wait for others to join so that we can start this event. But before that, let's kill some time. So you can wait a minute. Let me see something. Then I can. Okay, okay, fine. Okay, fine. It's done. Hmm. Hello, 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 hello. Live chat. We are still waiting for the audience to join us so that we can start this event further. Let's wait for 5 minutes more. After that, we will start this event. So today our event is new generation computer vision, as you all know. But still, we are waiting for more audience. Let them come so that we can start. I hope people can join as fast as they can because we have less time. Hi, hello, hello, hack version. So let's kill some time before that. Hello, Akash Pandey, how are you? What's up? What are you doing these days? You can say these days. Ah, you can also say that the happy days are coming back. College is going to reopen very soon. We hope so. You can pin your message, you can pin your thoughts in the live chat right now before the event. You can ask me anything. Hello. End semester exam. Okay, it was good. End semester exam was good. अब की बार तो सबके अच्छे गए होंगे वैसे भी घर पे बैठ के देने थे मेहनत करके दिए सबने एवरीबॉडी वर्कड हार्ड let's wait 5 minutes more so that we can start this event. And this event, as you all know, as you all see on the screen, this event is about new generation computer vision. It means we will talk about machine learning, artificial intelligence, stuffs like these. and this will be delivered by Anustup Mukherjee. So let's 5 minutes more so that we can start this event. 5 minute more, just 5 minutes more. But before that, you can talk to me. You can talk about anything. You can ask me anything. You can ask which year, right now, which year I'm doing. Akash Pandey. Ah, hack person. Hmm. So before if event starts, I want to ask you guys something that anybody knows what a new generation computer vision is, what machine learning, what AI, and what other scopes they contain in the future. If anybody know, then they can pin that in the comment section in the live chat. Can anybody know what is generation computer vision? Okay, so right now let's start this event. Hello and very warm good afternoon. Hello and very warm good afternoon to one and all present here. I am Nishal, and today this event is about new generation computer vision. And today our speaker will be Anustup Mukherjee, who is executive member of Mozilla Chandigarh. So Anustup, you can take you can take over from us now. I hope I wish you luck.
Yeah. Hi everyone. Thank you for the warm welcome, Nishal. So yeah, am I properly audible, Nishal? Can you please give me a warm
Yep.
confirmation about that?
You
Am I
are
properly
yes,
audible to everyone?
yes. You are properly audible. You can deliver.
Okay. Yeah, great. So today, as you all know, like today the topic is the buzz in the industry right now. Like buzz in the entire IT industry is the new generation computer vision, or what do you feel by artificial intelligence, right? So we will be talking today about some highlighted concepts and the best concepts of artificial intelligence, and obviously in the heights of computer vision, and how the new era is tackling with the new generation problems. So this is all about a very single line definition about the talk. Right. So before coming to the talk or jumping onto any other concepts, I want to speak about myself. I'm at present a computer vision engineer at Dark Horse Inc. USA, former lead AI engineer at Omdena. Also, I had worked with 3+ companies in AI developments. I also hold papers, publications, patents, book publication on IGI. I researched with IIT Bombay, worked with IIT Patna, and etc. etc. That's it. So you can also connect with me on the LinkedIn or Twitter or any other platform you want. Right. So, so before coming or jumping to any concept of computer vision, we have to know how does this computer vision or behaves, or what does this term CV means, right? So CV is something like you are approaching to a computer, and like you are waking up in the morning and you are simply taking a photo of something else, or suppose you are trying to open or log in into your phone. Now, every time when you try to log inside your phone, it used to ask for some kind of fingerprint or some kind of passwords, or sometimes it asks for an image of yourself, right? So yeah, so what does this happens? Because the machine or a phone want to check whether this person is exactly my admin, or this whether this person is not my admin, like it is someone else who is trying to log inside your phone. So it is simply a decision making system that every kind of machines used to have. Like in general sense, or in a layman's language, if I speak something like this, is the power of a human brain, or when a machine can have a human attribute, right? Like here you can see in this very small cartoon, like a computer is seeing a lady who is eating so much of food, and a computer is telling the lady like, hey, don't eat so much of food, you are already a big fatty. So like, yeah, this is the term, or this is the actual one single line definition of computer vision. When a computer or when a machine have a power to judge, or have a power to analyze a concept or a real time scenario that is happening all over and around. Yeah, it is something like that. So yeah, so before coming to again the bigger concepts, I want to just tell about the CV a bit more in a different language, in a Moravec's paradox, or whenever we talk about artificial intelligence, whenever we talk about a special power of machines, we have to come through the paradoxes. Like paradoxes in the sense, because most of the problems in the artificial intelligence, or most of the problems that we tackle in the field of machine learning, is somewhere or somewhere else is parameterized or biased. So we have to take some examples of some hypotheses and the paradoxes, like the same paradox that we have right now, and most common paradox that we used to deal in the field of CV is the Moravec's paradox. So Moravec's paradox is a very simple paradox that actually based on a biological concept of Darwin's theory of evolution, and it used to see or speak like that, like when a computer will learn or when a machine will start learning different concepts over a series of time, or different parameters over a series of time, when a machine will have the capability to learn over some topic or get trained and then give a real time output, then it will keep on leaving aside the unimportant concepts or some kind of unimportant parameters. It will not take care of some smaller parameters because it is now getting trained over and over with the new sort of parameters, right? So it will judge or it will take input of the newer ones. It will keep on forgetting the previous one, and which is actually the evolution, or which is actually being tends to be the evolution of machine learning. So right now, when Moravec told this kind of concept, right now we are using the same concept in computer vision. Now, this single paradox is the birth, or this single paradox is the statement of the new generation computer vision. Why? Because whenever we talk about computer vision, the first things that comes in our mind is a facial recognition system, is a number recognition system, or maybe it is number detection, or maybe it is face recognition, maybe it is object recognition, or maybe it is object detection. Like we always get tackled into recognition or detection. Did we ever spoken about generation? Do machines or do artificial intelligence have the power to generate something? Yeah, we have that power right now, and this is power, like we in the terms of Moravec's paradox, it's a mathematical theorem actually. It used to speak like when a machine gets trained on numerous time on a same parameterized level, it generates something new. And this is actually the trend in CV models. Like you can see, we started with simply cognitive judgments in artificial intelligence. Then we jumped into augmented reality. We jumped into virtual realities. Now we are living in an era of generative learning. That is called GANs. It's a very basic or overview. You might tell a cloud structure of this talk. Okay. So yeah. So before coming to any new generation concepts, I want to speak more about the previous ones, because previous topics is the base of everything. So like again, I have plotted out a cartoon over here. Like it used to speak about the most spoken concepts or most spoken examples of artificial intelligence in computer vision. So like yeah. So generally, whenever we speak about computer vision, as I have already told, we speak about recognition or detection systems. We speak about tracking. We speak about object detection. So like take an example over here. Suppose you are a Spider-Man. For the time being, just think yourself as a Spider-Man and you are coming out of your window and you want to jump from one building to another building. What is your brain thinking at this moment? Because whenever we speak about machine learning, whenever we speak about CV, whenever we speak about AI, we have to know, we have to understand what is happening actually behind our brains, or what is actually happening behind the scenes, right? So yeah, so just pick an example. Suppose for a time being, for an instance, you're Spider-Man, right? And you're coming out of the window and you want to jump to that building, right? So yeah, so like what your brain will think at this moment? Your brain will think of a pathway. Hey, I will be jumping to the left building or the right building. Okay, it's a second base decision, but first the way through which I will jump, is that way clear? Is there any obstacle, or is it completely clear? So you have to understand whether my path through which I am going to traverse is clear or not, whether it is full of any obstacle or not, right? So what kind of algorithm or what kind of processing your brain is doing at its back end? Your brain is simply taking a decision. Your brain is simply creating a decision by detecting the objects. It will first detect whether in the path there are some objects being present or not. Or yeah, if it is being present, then it will give you a decision. Okay, you cannot choose this path. You have to go to another one. If it is not, then it's okay. So it is a very basic problem of detection. Like I'm detecting, it is my destination. Like it is a building. The yellow building is my destination. Now, when I am telling the building, like I want to go to the left building is my destination, it's very well and enough answer. But when I am specifying it to be yellow building is my destination. Like you can see over here, Spider-Man is trying to move wave on a yellow building over here. So when I'm specifying it to be a yellow building is my destination. So yeah, building is obviously your computer vision model or your brain is detecting it to be a detection problem. It is detecting actually at a backend. But if I speak about why yellow and why the brain is speaking it to be only yellow building is my recognition or only yellow building is my destination, not the red building is my destination, not the bluer ones, because the brain is actually recognizing the color. It is side parsing or it is adding a new attribute to the problem statement that you are dealing. It is telling, okay, the place where I want to go is a building, but the building must be specified. And a specific building is the yellow color building. So now the question is, building is a detection thing because I can easily use any detection algorithm to specify which is a building, which is a road, which is a sky, anything out of that. But how can I recognize it to be a yellow building? Here comes the recognition algorithms. While I have seen whenever I used to train students, like most of the students get confused in the concept of detection or recognition. What do you mean by detection and what do you mean by recognition? Sometimes they feel it to be the same concept, right? Actually, there is a very fine-tuned difference in between these two concepts actually. So once is called detection, like yeah, if I want to reach to this particular destination, it seemed to be my detection part. I have detected, okay, this is my scenario, scenario place that I want to go. But yeah, when I'm recognizing some kind of specific places, or when I'm recognizing some kind of specific areas, or when I'm giving a specific attributes to it, the yellow place only I want to go, not the red place, or the blue place I want to only go, not the yellow place, then it is you are recognizing the place to be that place is your own. So now the question comes, what do you mean by segmentation? This is another big problem that is being discussed in the field of computer vision. So yeah, what do you mean by segmentation again? Segmentation is means like you are living in a room. Suppose it is your hostel room and you are living inside it. So segmentation is like, suppose you are living in a three-seater room. The three guys are inside your room. Now it doesn't, like, it is not a reality that the all the things that is being present in the room is completely yours. Some kind of objects which is present in the room, maybe your friends, sometimes other persons, or some things that is present is yours. Like the guitar that you are having is yours, and a kettle is having on the room that is your friends, maybe, right? So how your brain understands which kind of thing is mine and which kind of thing is not mine? This is actually the problem of computer vision, which is called as segmentation. Segmentation is a special type of algorithm that segments out. Now, what are the parameters of the segmentation? I will speak later on this talk. What are the parameters of the text segmentation? What kind of decision attributes artificial intelligence is taking at the back end of the segmentation techniques? But in a layman's language, if I define segmentation, that means if I speak in Hindi, apna saman apne aap dekh lo. That's it, right? What do you mean by tracking now? Now, yeah, when I am speaking about tracking, then tracking is a very declarative word inside its own. Tracking is obviously, suppose you want to go to your home to another friend's home or any other home, right? So you will obviously follow a path, right? So it is something called as you are tracking the path over the map, or you are moving somewhere else. You are tracking every kind of records, where you are going, where you are not going, what things you are doing and what things you are not doing, everything when you are tracking out. Yeah, this kind of tracking algorithms, right? So these are the very basic problem statements we discussed right now with the computer vision. Again, I am just summing it up, like detection, recognition, localization, segmentation, tracking. This kind of things are the most discussed computer vision problems, and whatever problem statement we deal is coming under this domain, right? So before coming to a bigger example, I will just deal a very basic problem with you guys. Like this is a problem that I want to deal with a facial recognition, obviously. But yeah, just let me have a like diagram out of that and just specify the problem statement. So now the problem that I am dealing over here right now is a facial recognition problem. This facial recognition problem, we will see what steps we will follow in a computer vision approach to handle with this particular specific topic, right? So yeah, whenever we speak about facial recognition, or whenever we speak about this kind of concepts of the facial recognition, the first thing that comes in our mind is like, yeah, like if I'm speaking about facial recognition, then there might be a system that will be recognizing a human's face, and at the back end it will be taking the decision whether this face is belonging to my admin or whether this face is not belonging to my admin. That's it. So this kind of this kind of basic decision a model will be taking at its backend, right? So this is a very basic concept of like facial recognition. But if we see the step-by-step approaches of it, and suppose you're working in a company and who are giving you a product of recognized faces. So now I will discuss the problem of facial recognition. So let's take a look on that. So suppose you are having a human face. Just I'm discussing this problem to let you guys know how computer vision models actually work at the backend. Just a very brief overview, because most of the times what happens with the student, we know how to call a CNN model from Kera's library, but we don't know how it works. That's it. So because if you want to jump into the new generation computer vision, where we are speaking about generative learning, we are speaking about mixed culture of deep learning and machine learning algorithms, then we have to know what is happening at the backend. So just I'm telling about the concepts of that. Yeah. So the concept that we are dealing, it's completely like, suppose you are having a human face. So this is a human face. Mind my diagram. Okay, just looking like a face, right? So yeah. So like this is a human face, and you want to create a detection technique. You want to create a machine learning model or a computer vision model that will detect this to be a human face, right? So yeah, you can do. What will be a step one? Obviously, when we speak about machine learning, we speak about 5 mantras. First, you need to collect your data, separate your data into training and testing, and then choose a proper algorithm based on your problem, do some sort of data processing, train your model, and then finally having an output and then test it up. This is a very basic scenario of machine learning mantra, or we can tell about this to be a 5-statement machine learning mantra. But yeah, what about computer vision problem? Like when we want to detect some kinds of face, what we can do? Sort of like first thing that comes in your mind, okay, if I see someone's face, when you see someone's face, how you judge the face? Maybe you will be judging the face by hair, maybe you will be judging the face by nose, you will be judging the face by eyebrows or eyeballs or lips, anything like that, right? So these are the ways to judge it all. But what can we do to judge a face by the help of a machine? This is our problem statement. So yeah, the very first things first, we will be collecting some kind of images or a 50,000, 10,000 image database that we always call to be a training DB. So now image is being extracted and passed to a ML model. Suppose any computer vision model I am using, maybe it is CNN, maybe it is anything. So the first thing that comes to make a judgment, you have to analyze the parameters. So what are the facial parameters? Because every image is having some sort of parameters. Whether you are processing any image, whether you are processing any video, whether you are processing any audio, everything is parameterized. When we are speaking about machine learning, when we are speaking about AI/ML judgments, everything is parameterized, and we have to pick up that parameters first. So suppose you want to judge a face, what kind of parameters you have to take care of? You have to take care of the parameters like eyebrow, nose, lips. For a time instance, I'm taking about that. Now, you understand what is lip. You understand what is an eyebrow. You understand what is a nose. But a computer doesn't understand. It understands some concepts of mathematics. That's it. So how I will change the logic into a code or a logic into a machine learning algorithm? So first thing first, like we can easily plot this out by using the power of matplotlib in any coordinate system. We can easily do it up. Now you have a complete coordinate base idea, like okay, this is my face and this face is extended from this to this. This is the coordinates of this face, right? These are the coordinates of this face. Okay, so you know from which coordinate to another coordinate this particular image is being extracted, because after plotting any 2D plane, you know how to get it extracted, right? So like okay, so finally you are done by plotting the particular image in a coordinate system. And after that, like when you are done with the extension or extracting out the coordinates of the face, now can you plot out the coordinates of the eyebrows? Yes, I can. I will be simply making something like this and simply calculating out the distance. Or suppose I want to going like this, I can easily calculate out the distance. So what things will be extracted if you are specifying a left eyebrow from coordinate this to coordinate this, a right eyebrow from coordinate this to coordinate this, lip from coordinate this to coordinate this, a nose from this to this. You are having the extracted coordinates. So just I am clearing my screen and getting to a proceeded up part, right? So yeah, So like, okay, now what kind of image we have? We have a plotted image, right? We have a plotted image and we know the coordinates. We know the coordinates of the eye, each and every eye, of the nose and of the face. We know the coordinates of that. For an example, if left eye equal to, I have a value, or suppose I am simply writing the coordinates, if right eye, I am simply writing the value. So this each and every features, or each and every things or parameters that is being extracted will be considered to be a feature, because left eyebrow is a feature, right eyebrow is a feature, lip is a feature, nose is a feature. That's it. So yeah. So now, when you are done with the understanding the feature mapping, or when you are done with the extraction of each and every feature, how will you extract a phase out of these features? This is the question. So when you want to extract a face out of this feature, you have to know the connections in between that. Because sorry, like your left eyebrow is connected with the right eyebrow. When you are seeing someone's face in reality, you are seeing a connected architecture, because your face is a connected system. But here I am speaking, I am extracting the coordinates of each and every section or parameters, where each parameter is signifying or each features. So how will I connect them, or how will I speak, or how will I extract a facial map out of it, or how will I extract a facial pattern out of it? Yeah, we can do it. We can calculate the coordinate distances from each and every coordinate. So suppose this coordinate distance is being calculated to be n. How to calculate it? We have a very basic simple formula in computer vision. Root under x2 minus x1 plus y2 minus y1 whole square. A simple Euclidean distance will work in this case. So now, after getting the coordinates and after joining each and every coordinate point, you will be extracted with some kind of facial map like this, interconnected facial map like this, right? And it is actually a facial pattern. Now, what does this facial pattern is actually? This facial pattern will be nothing but a collection of numbers which will be signified it into a matrix, or which we even tell in the technical language feature matrix or a feature map. And now this feature map will be processed in a computer vision algorithm. So this is how computer vision understands an image. Most of the time we don't know how a CV model understands an image. That's why we used to keep on relying on the pre-trained models. But when we want to create a solution by your own, you have to understand how a CV works. And this is an example of how a CV works on old generation. So now let's come back to our presentation. So yeah, the thing that right now I have told is completely being visualized over here. Complete extraction of the facial map is being present over here. And finally, when this facial map or a facial pattern, whatever we can say, is extracted, now we can easily pass it for detection for any kind of facial recognition architecture, right? So the very next things, now we are done with this kind of judgments. So when we are done with this kind of judgments, now like we have seen how a facial recognition works. Now this is the time to plot out the problems, or plot out the difficulties of the old computer vision, or plot out the difficulties of what the previous problem is happening. The previous problem that we right now had discussed is having a very big problem. Suppose, for an example, uh, you are working in a company, sports company, right? Even right now I used to work in an AI based sports company. So okay, suppose you're working on a sports company, or any maybe surveillance or any police department, you're working as an AI engineer. So what kind of problems do you have over there? In the reality, on the real time, in our real days, or in a real life, no one is static actually. Everyone is moving from one point to another point, another point to another point. Everyone is moving. So when we are in motion, our image is dynamic. We are not static. So our image is not static. It is completely dynamic. So when it is dynamic and when it is in a greater speed, then what happens? What kind of problems? When a computer vision model will read the image, or the output image will be hazy, or a output face of the particular person will be hazy, right? It is something called as a hazy image. So how can a computer vision model will detect a hazy image? Or okay, I can detect it to be a person from a hazy image, it's okay. But when I am speaking about a face, which is a very sensitive part, can I detect it if it is coming to be so much of hazy? So it's a very big problem right now. Just a second. Yeah. So like, yeah, so if the particular image comes to be hazy, so I cannot detect it from the old computer vision, because in the old computer vision I'm speaking about extraction of facial patterns, extraction of coordinates. So the thing is coming hazy. Where can I find the coordinates? Where can I find the pattern? Problem. Another bigger and bigger problem is like, okay, what if happen, suppose the image that you are taking input, the image that you are taking input in your computer vision model is a very small image. For an example, you are making a surveillance camera, and the surveillance camera is taking input of a very small image, because the criminal or a person who you are tracking is far enough from the camera. So the input image in the camera will be really very small. So when the image is really small, where can you find a person and where can you find a face? Obviously this kind of thing might happen. Another biggest problem in reality, our face is not same from the birth and our old age. Our facial patterns will keep on changing, and the biggest change of the facial pattern from 2019 to 2020 is our face masks. Or sometimes some 1 year before I am not using eyeglasses, and now I am using eyeglasses. When I am using eyeglasses, my pattern will be changed. So do I have to update my database every time if my facial pattern might be changed? It's a very big deal, because the thing is very slow now. So this kind of problems we are discussing in the previous architecture that we have right now suggested. So the previous architecture speaks about a facial recognition problem by using an algorithm and by using extraction of the facial pattern architecture, and that architecture is speaking about some kind of logics. Just a second. Just a second. Yeah. So what will happen if the facial patterns get changed? Now the next question is, if I am having an input image and the quality of the particular input image is very poor, right? This might happen because every time we cannot support a 100K or 720K video or 720K image, right? Might we have a low quality of image that we need to bear up, right? So can a computer vision model can go with this kind of problems and can deal or tackle with this kind of problems? Yeah, we have a solution to this all. So what is the solution to this all is actually the birth of new generation computer vision. So just I am getting back to the previous problem, and I will be redefining this previous problem with the highlights and architecture of the new generation computer vision. So what are my problems? My problems is, biggest problem is poor quality of an image, because if I am talking about a hazy image, it is also very less quality. If I am talking about a blurry image, it is also of very poor quality. If I am talking about a small image, it is also an image of a poor quality. So this is a problem if a image quality is less, right? Just a second. So if the image quality will be less, what can I do? This is the problem. The second problem that we can deal is like, okay, so after a poor quality of the image, what kind of other kind of problems that we are dealing? If your facial patterns is getting changed, what kind of facial pattern you are dealing, or what kind of facial pattern you are having today, it might be changed tomorrow. So a change in a facial pattern, or a change in a facial map, or a change in a facial map, right? So this might happen, right? Okay. So like, if this kind of things happen, just I'm speaking about these two problems right now. One is a poor image quality, another is the poor facial like change in a facial pattern, right? So if this happens, how can I deal with this in the case of the computer vision or a new generation computer vision? So how we redefined our architecture? We redefined our architecture in this manner. Like, okay, suppose I'm taking an image. This is my image. It is a very poor quality image and a very small image, maybe 32 cross 32, right? A very small image. So when I am inputting this image, what kind of things that is coming in my mind? If I can increase the image quality, or if I can increase the image pixel, or if I can remove the blurriness in an image. Can I do that? Yeah, you can do that. So let's see. And this is actually the birth point of the new generation computer vision. This is actually from where the new generation computer vision is being started, right? So okay, so right now okay, so yeah, so let us get back to the problem. I am having to the input image, and this is my input image, which is completely a poor quality image as well as a hazy image. And yeah, this poor quality and a hazy image also are very smaller in size. So what will be the first step? The first step that comes in our mind, or the first step that we need to do very firstly, is completely like okay, I can de-blur an image. So if you want to de-blur an image, what kind of thing you have to do? Just I'm drawing the architecture. It will help you guys. So this is my input image, which is having the previous problems. So now our first thing that comes in our mind is a de-blur. So to de-blur an image, when we are having any real life image in our reality cases, what things we are doing is actually a thing that is called as the something like okay, I am doing something called as a deep blurring effect, and this deep blurring effect is being done on the particular part. Okay, I am simply taking an example of any OpenCV filters. If you are taking any example of any OpenCV filter, yeah, it can do some kind of deep blurring for your case. So you can go with an OpenCV filter first, and that OpenCV filter will be enhancing the pixel quality in your case. That might be an option. Even if you are a high level engineer, you can go for a deconvolutional technique. Deconvolutional technique do nothing. That changes the image matrix's value. For an example, you are having a pixel quality of 32 cross 32 at the back end. It will be deconvoluting it into any other value, and that will be increasing the pixel quality. So this is the very step one of my problem. That means what I was doing previously is a direct facial pattern extraction. Now I am dividing the problem into some statements. So what are my statements? My statements is, first I will be having the image, and then I will be passing the image for a deconvolution or a blurry effect removal. I guess most of the people of us used to use several kind of image filters. Like image filters means image sharpening or like image smoothing, that kind of things we used to use. Even you can use that kind of tools. So yeah, so we are passing it to any kind of OpenCV filter or a deconvolutional filter. So when you are done with the removal of the excessive blurriness in a particular image, or when you are done with the removal of the excessive haziness in an image, now your image is something good. Okay, my image is something good and something running in pattern, right? So you can do that. So you will be having a little bit of processed image. Now what is my next problem? What is my next problem is my image is extremely small in size, and my image is also having haziness that I have right now removed. But though there are some parts of the image that cannot be properly understandable, right? So how can you work in this case? Here, suppose if I cannot understand the proper each and every sections of my face, no worries, no worries. But you can extract a skeletal architecture from your face. For an example that we called as canny edge detectors. You can take the help from canny edge detectors to detect what are the edges of the face that is actually being present, and that will also work as an image auto completion. So our target over here will be to extract a processed image, or to extract a face that doesn't having that kind of previous uncompleted parts. So yeah, I have the particular edged patterns, I have the particular edged face after doing something called as an edge detection. I have. And now your now your facial image is ready. Now you can pass it to convolutional neural network for detection, facial detection. Now you can pass it to ResNets. Now you can pass it to any kind of network architecture for a detection. But what is the new generation, or what is the difference? Difference is changing image processing. Here you have the power to change something. You have the power to change the existing state of art. You have the power to redefine the problem on your name. Like here, we have redefined the problem. We had the problems of hazy image. We had the problems of the blurry image. We had the problems of the small image, but we handled it. We did deconvolution. We removed haziness. We removed blurriness. We used OpenCV filters. We processed the image. We understood all kind of color distribution in a particular image, and my image is now ready. So this is the starting of new generation computer vision. I will be telling more and more about the problem, more and more. now get back to the presentation. Yeah. So, okay. So like another example, because I have spoken about the facial recognition system. Now I want to detect some kind of things from OpenCV as well, because most of the students is like well and heavy frequent with OpenCV. So like whenever we come into step into machine learning, or whenever we step into artificial intelligence, every one of us merely speaks about OpenCV. Hey, I know OpenCV. Hey, this is this kind of detections I can do with OpenCV. It is a very cool thing indeed, right? So yeah, so I will be speaking about OpenCV. So here you can see I am telling about a problem like okay, it is actually a traditional computer vision, and I have to do a ball detection system. So ball detection system means I have to understand, like I have to tell what kind of in which section blue balls are present. So this is my problem: detect the blue ball from the basket, or detect the blue ball from the market, or detect the blue balls from the image. This is my problem. So how can you solve the problem? Because just understand how we are solving machine learning problems. Because if you don't know much algorithms, you can learn it. If you don't know much about that kind of backend programming, you can learn it. But for the logic buildings, you have to understand how an algorithm is processing at a backend, or how the models used to act in the backend. Because machine learning is all about mathematics, and machine learning is all about logic building. That's it. So just this is my problem statement to detect the blue balls. So how will I detect them? So if I want to detect the blue balls from the basket, the only possible way for me to analyze it is completely, yeah, color based detection. I am open to do some kind of color detection. I will be using the detection of color techniques, or color detection techniques, and I will be detecting in which particular segments, or in which particular areas the blue color is being present actually, right? So this is my way out I can do. Okay. So yeah. So now the next thing that comes in my mind now, hey, so I am detecting the color. Now, how does this color detection algorithm works at its backend? This color detection algorithm works either by judging the RGB value, or sorry, RGB color distribution, or HSV color distribution. So now the question that comes in your mind, okay, it is detecting the RGB values or HSV values. Think step by step. I am having an image, and I will be detecting the RGB or HSV value of the objects present over it. So obviously each and every colors have different RGB values. So it is merely, or in a layman's language, it is pretty easy. If I detect the RGB value distribution, I can say, okay, in this particular section, the blue balls are being present. But the problem is, or where is the problem, or where we are stepping in the problem, when you will be doing this kind of problem statement with this kind of RGB value analysis, you will be getting a very less accuracy. The reason is problem in masking. What do you mean by masking? Masking is something, that kind of image you can see over here. I have this particular places, I have detected the color, and then for detecting the regions, I am masking out black and white. That's it. So this is a problem. This is a problem that we can face in the region or the part of the masking. So why there is a problem in a masking? Masking understands each and everything on the area of its distribution. Now the area of its masking is not a special power. Masking is actually fixing up any proper value, and just only keeping that particular value or object, and removing all other objects. That means only I will keep the blue balls over here, and the rest objects will be in the black zone. That is actually what we mean by masking, right? But the question is, but the problem is, like, okay, this masking some 90% of the time is giving us a uneven distribution of an area, or uneven distribution of the space, right? So like if it is giving an uneven distribution of area or uneven distribution of the space, obviously my detection will be wrong. So like here, how we are tackling this traditional problem with OpenCV. So yeah, we are tackling this traditional problem with OpenCV again. I am simply detecting the color and saying, and then finally masking it and telling in this particular section the blue balls are present. Now I am telling about the problem. Problem is, if the color detection is not proper, if the color distribution range is not proper, this kind of things might happen. Because suppose two kind of balls are present side by side, for an example yellow and red, whose RGB values are very proximal, very near values. So if these two kinds of values are present side by side, OpenCV filters cannot detect these two kind of proximal values. They will detect it one. Now you will detecting B, then finally your output will be detecting yellow ball, detecting red ball, where you want to detect only the red ball, but yellow is getting already detected. So what are the other ways? What are the other ways you can detect this kind of problems? So for an example, I am picking right now another problem statement for the sake of your guys, and just I will be redefining the problem in this also. This is a like these are the very short projects inside it. You might tell, right? So the problem is what we are dealing right now. I have a ball. I have several kind of things present in the several kind of things being present in the basket. Just a second. Am I audible? Am I audible? Am I audible?
Yes, Anustup, you're audible.
Yeah. Am I audible? Hello.
Yeah, you're audible.
Okay. Sure. Just like I thought. Yeah. Okay. So yes. So like where I was. Okay. So yeah, I was in a part of that kind of problem distribution or a problem technique distribution that I was selling right now. So in that particular problem distribution training, like okay, I am telling like okay, I have a basket of that kind of balls and which is having uneven distribution of the colors or proximal values of that kind of things. What I will be doing. So here comes the stepping in of the new generation computer vision. New generation computer vision will not only speak about the RGB color distribution or not only speaking about the HSV values, or will be not only relying on a masking concept. Rather, it will first analyze the space, it will first analyze the size, it will first analyze the volume. That's it. So okay. So how can we detect accordingly? So we can just let me draw any other color of balls over here. So yeah, so these are the two different kinds of the balls being present, right? So yeah, so now what we can do over here, I am having the basket colors of the balls over here, and now I want to detect, and I am just drawing two kind of proximal balls, like black and violet is very proximal in region. So first I will be passing it for a color detection. Simply I will be using a color detection algorithm which will be using the logic of RGB or HSV value analysis, and by the help of an RGB or HSV it will be detecting the color of, suppose I want to detect any kind of violet color over here, I can detect it easily, right? I can detect it easily. Now when I am done with this kind of detection, now I can easily segment out that kind of violet balls. Now I am taking a preference, that like okay, because this kind of two kinds of ball is having some kind of similar proximality or similar kind of proximality, or the colors the RGB values are very similar in preference. So like okay, this kind of things will also come into my observance, right? So like okay, so now the next thing that comes in my mind is okay, now I am done with this kind of color detection. What will be my very next step? So I have to understand the shape and size as well as the region distribution. So this is kind of concept, like if I can analyze in which particular section or in which particular areas this violet color or the single line violet color is being actually being distributed or regionally distributed or proximally distributed, then it will work for me, right? So then I will pass this thing for a shape and size distribution detection. So it will be detecting or segmenting out in which particular section the shapes and the size being actually present of, right? So it will be detecting the shape and size. Now I will be having a far level more distribution thing, like okay, now I can just segment out, okay, in this particular section this kind of violet things are present and a very few black balls I can just segment out over there. So now I will be having a processed image in which I can now do the masking to have the proper detection. If I cannot do, then what are the other way? The other way is called as the segmentation. So let's jump into the concept of segmentation. So before coming to the segmentation, yeah. So what do you mean by segmentation? Suppose there is a room. In a room, there are several other types of objects. Suppose it is a rectangle. Suppose it is you. Suppose it is something being present on a ceiling. And you want to tell like, okay, this particular object is mine. You have to segment out this particular object. And this particular object is not mine. Then you have to also segment out in this particular object in a different color, right? So yeah, so how we'll be doing this kind of thing? By using a logic of segmentation. So can I use this kind of logic of segmentation in our problem? Yeah. So now the question that comes in my mind is, how does the segmentation works at the backend? So the segmentation understands some kind of things like color analysis. It will be analyzing the colors being present over there, or the variation of the color, not the distribution, how the color is varying, or how the color is being how is the color is being varying in from one frame to another frame, or in one particular section to another particular section, how the color is being changing over the time. So I can easily judge the color variance, or I can easily judge the color distribution, HSV color distribution, or HSV color variance. On the logic of the variance and distribution, I can easily say, okay, this particular thing is not mine, this particular thing is that. Accordingly, I can segment it out. So yeah, now if I am having the processed ball of this kind of violet as well as the blacks, and if I am adding some kind of segmentation technique to it, for an example, I am using a RCNN algorithm or CRNN algorithm, or any other. For an example, I am using detectron algorithm, any kind of new generation models. So yeah, it will be segmenting out only this particular section is lying in the violet section and other is completely black. So just since I am talking about segmentation, so I want to show you a very good example of some kind of segmentation techniques, because segmentation is one of the most like thing that I have used to discuss in right nowadays. Like, and one of the better algorithms why segmentation is needed, because segmentation is needed. Suppose for an example, you are working in a security based system. In a particular security based system, like you are just coding some kind of computer vision model, like you're simply coded up some kind of computer vision model, and that computer vision model is detecting which particular person is carrying out guns. Then how will you detect them? Obviously you will be not every time you will be not adding any kind of person recognition technique or facial recognition technique. You have to make something that will be statically segmenting out the problems or the problematic persons out of the frame. So here comes the application of the segmentation techniques. For an example, I am having a house over here. This is my house. I am having a house over here, and I want to detect, I want to segment out sky, I want to segment out the house, I want to segment out the road. Yeah, you can do your segmented image. Your segmented image will be this kind of thing, and it will be showing completely an output to you guys. That's it. So this is some kind of basic overviews of the new generation computer vision. Now let us proceed to the next example, because fairly a very many things being need to covered, but I will be speaking about the most important ones. So yeah, so this is another example of the segmentation by using the power of the detectron, right? Now the question that comes in our mind, sometime before in the facial recognition problem I have talked about, okay, if a person is in a motion of, or in a, if a person is in a flow, or in a, if a person is moving from one part to another part to a very at a very high speed, how can you detect that person, or how can you detect the face of the particular person? Can you detect it? Yes. In new generation computer vision, we have the power of that kind of detection. How we have the power, and what was the traditional power? The traditional powers, now I am talking about a very important concept over here. This concept is the logic of tracker. For an example, you are having an input video. This is your input video. You are having a video in the input, and now that particular input video, now what does this videos is actually at the back end? This videos is nothing but some kind of collection of images, right? Some kind of set of images or value of images. That's it. So when I'm having that kind of set of images together, I can tell it to be a video. So for an example, I am telling this is a person who is running at a very high speed, right? Suppose from one frame to another frame. This is the person who is running at a very high speed from one frame to another frame. This is frame 1 of the video. This is frame 2 of the video. So if you just judge the concept very carefully, or very confidently, or very importantly, you can see whenever there is a transition from one frame to another frame, there is obvious or there is obviously a change in coordinates. Something called as a change in coordinates used to take place, because suppose a particular person is standing, for an example, is 2 by 2 and 3 cross 3 coordinate at this particular time stamp. It is obvious that in the next time stamp the person will not be standing over the same place, or the same side, or in the same pattern, because its orientation might be changed from 2 by 2 to 4 by 4, right? So there should be some kind of change in coordinates from one place to another place. So if I can judge how the coordinates is changing from one frame to another frame, uh, my game will be done. I can easily do what I am thinking. So can I do it? Yeah, you can do it. This power is being enabled to you guys by a simple thing that is called as an OpenCV tracker. OpenCV trackers. These OpenCV trackers are nothing else. There are many types of trackers: CSRT tracker, KSF trackers, Gotron trackers, many type of trackers being present in OpenCV. A simple drag and drop code, and I have to call a single function over there to track anything. So if you need to track anything in OpenCV, you can use any of these kind of trackers. But what this trackers logic is using at a backend, they're nothing but they're using some kind of coordinate mapping techniques. They're simply going to match what was the previous coordinate and what was the new coordinate from one frame to another frame, or over the frames. That's it. So yeah. So now I can track the coordinates. I can track the coordinates if the person is in a motion. That's a very fair and fair answer. But if the person is at a very high speed, and suppose within a frame, two times a coordinate is getting changed, because the person is running a marathon, person is roaming all around. How can you detect this kind of problem? Because if the coordinates is changing within a microsecond or within a millisecond, obviously for 0.01 second a frame is being depicted off. Within a frame, suppose a 3 time coordinates it is being getting changed. How can you detect this kind of problem? This is a problem in computer vision. So we can detect this kind of problems. If you're making any type of projects like that, you can use an advanced concept of something called as an optical flow tracking. Optical flow tracking. So what do you mean by optical flow, or what does this optical flow actually stands all about? So this optical flow is nothing else but it's again some kind of logics that comes from the back end of a coordinate system, but it actually speaks about the pixel management. That means how, because whenever a coordinate is changed, whenever a person's motion is changed, whenever a person's posture is changed, its optical flow is getting changed for every time, right? So its optical flow is every time is getting changed. That means the pixel is changing every time, or the pixel value is getting changed every time. So you have to track how the value of that particular pixel will be getting changed from one frame to another frame. Obviously you can track how the pixel is getting changed, obviously. So this is the logic of the optical flow, which is very much common in the case of the kind of computer vision right now. So based on this logic of the optical flow, or the logic of this kind of pixel traversing or pixel mapping, what kind of algorithms you guys can use? You guys can use an algorithm that is called as a pix to pix. Now I am telling some kind of good points about this algorithm called as pix to pix. Pix to pix will be not only speaking about the pixel translation, or a pixel, how the pixel is getting changed over the frame. It will be also taking the account of the coordinate management system, or it will be also speaking along with the coordinates as well as the pixel, how both things are being changed over the period of time. And if you are only wanting to concentrate, no, I cannot calculate so much from the coordinate end. I will be going for a simple procedure rather one. Then you can go for an easy algorithm that is called as the flow net. Right. Let me get back to the presentation. Here I have shown you guys what do you mean by the flow net section. So yeah, so this is all about the flow net. Like it is how the pixel is getting changed from one frame to another frame.
Hello,
Right. So this is an
Anustup.
example.
Hey, chat.
Yes, hi.
Hello, Anustup.
Yes,
The
hi.
private chat.
Okay, just a second. uh, okay. So yeah, okay. So I am in the next verge of the end of this kind of end of this kind of thing, right? So yeah, so we are done with how kind of flow nets being traversing, as well as how this kind of pixel traversing is being doing all about. And just I am going to show you some kind of basic examples, like yeah, how can this 3D mapping, another important concept of the computer vision, takes place actually. Like the 3D mapping is being taken place. This is another example. This is another example of the segmentation techniques. And even by using the power of segmentation, or even using the power of flow tracking, you can see how the ball is getting changed from one frame to another frame, right? Like it is another biggest example of the algorithm that is called as a tracknet. This tracknet algorithm is to track the ball and even smaller and smaller objects. And one of the most boom in the industry right now is the power of the generative learning. And the power of the generative learning is something like, okay, it can generate its own image, as well as it can generate its own power, as well as it have the power to generate something, and having a generative power. So here you can see I am having a very still image. I am having a single still image and just passing the flow and passing the coordinate systems over there, right? So yeah, so like, okay, so at the end bit, like, because we are actually running out of the time, so I have to tell, like, okay, you can deploy this kind of powers of this kind of advanced algorithms. Like if you're having this kind of advanced algorithms, you can easily deploy it over the Raspberry Pi, or you can easily deploy over it the Arduino systems, or you can use the power of TensorFlow Lite, because TensorFlow Lite will be helping you more in the deployability. So if you are having the power of TensorFlow Lite, you can easily be deploying it into any kind of hardware systems. And yeah, so this is all about a new generation computer vision, where a new generation computer vision is speaking how we are redefining the problems in a new end, and how we are doing a distributive management of the problems, how we are dividing the problems in several distributed parts, and finally we are dealing with one and every part and doing another level of parameterized training. Thank you. And if anyone want to connect on me on the LinkedIn, they can. And if open to queries, if anyone have any type of query.
Thank you, Anustup. Thank you,
Yeah,
Anustup.
hi.
Thank. Sorry, it was a great event. Even I've learned some new things thanks to you, and I hope they also learn some new things. And this video will be on our YouTube channel. You can watch anytime if you want to read something, recall something. You can watch it here. So thank you all for attending this event. I sincerely thank you from the depth of my heart. And you can connect with us on LinkedIn, Instagram, Facebook. Handles will be shared soon in the WhatsApp groups. And feedback form also, and feedback form, it that also will be shared in our WhatsApp group. And make sure to fill that form. Thank you all. Have a nice day. Have a nice weekend. Goodbye. See you.